Oh, good day, everybody. Didn't see you there. Thank you so much for inviting me to participate in Dev Around the Sun. This is an amazing, 16 hours of talks now? So my name is Kris Howard. I'm web_goddess on Twitter, if you want to tweet me. And I've been working in the tech industry for decades now. These days, I work as a solutions architect manager at Amazon Web Services in Sydney. And I'm coming to you live from Australia, that's right. Where, as you can see, my home office is also my craft room. That's right, I'm a crafter. I knit, I sew. I have been known to dabble in the occasional cross stitch or quilt even. I am your crazy crafter friend. You know you've got one. The ones that you send those really hilarious memes to, right? Like these. Yes, these are actual images that people have sent me since we've been in COVID isolation. And people, let me tell you that I have two main problems with this. First off, I'm a knitter. And this is crochet, people. This is totally different. And this is a super important distinction that the non-crafting muggles get wrong every single time. Okay, this is the crafting equivalent of confusing Java and JavaScript, all right? Just don't do it, okay? And secondly, whatever. I haven't even made that much stuff in the past 2 months. I mean, sure, I prototyped 3 different face mask patterns and wrote up a blog post about it, but who hasn't, you know? I've only made 8 of them so far in total. And I mean, beyond that, well, I repaired an old handmade quilt by adding patches and doing some hand embroidery on top. I sewed a t-shirt and prototyped 2 different trouser patterns. Nothing unusual there, right? And knitted myself a top-down 4-ply Fair Isle jumper. I'm sure you've done that much, right? That's not excessive. I'm not weird or anything. And if you follow me on social media, in the past week, you might have seen me actually working on this. Or I'll bring up the slide as well. Yes, I am in fact knitting the coronavirus genetic sequence into a scarf. This is actually not that difficult to do. So I went to the National Center for Biotechnology Information, their website, and I looked up the nucleotide sequence for SARS-CoV-2 to give it its proper name. And they actually have about 3,500 different variations on there. I went with one from Florida because why not? And so I copied and pasted 150 lines of that on my iPad, and I assigned each of the 4 letters. You remember Gattaca, G, A, T, and C. I assigned each of those letters to a different color, and then as each letter comes up in sequence, I knit a stripe and tick it off. And now a few folks have actually messaged me on Facebook and Twitter being like, "Ooh, is it long enough to do a really long scarf like Tom Baker on Doctor Who?" So last night, I decided to actually calculate it out, how long this scarf could end up being. So based on the sample I've knitted so far, if I knitted just the sequence I copied, which was just a tiny fragment of the entire nucleotide sequence, my scarf would end up being 45 meters long. So no, I am not knitting the whole damn thing. I'll just knit until I get bored or until we get out of isolation, whichever happens first. So yeah, if you didn't already know, knitting and textiles in general are really great for encoding information. And you don't have to just use colored stripes. I mean, if you've ever learned to knit, and I know a lot of people did when they were kids, one of the first things you learn is that there are actually only 2 stitches, knit and purl. That means knitting's inherently binary. And binary, to computer geeks like us, that means we can use it to code pretty much anything digital. You could, for example, combine knits and purls into ribbing and make a beanie. So this pattern here, this hat is called the Decoder Hat by Zabit Stewart. It encodes up to 12 ASCII characters in binary at 8 stitches each. This is basically a form of steganography, of hiding a message in plain sight. And knitting is really great for this. Did you know that in World War II, the Belgian resistance recruited little old ladies who lived near rail yards to watch German trains and secretly encode their movements into their knitting? She doesn't look so sweet and innocuous anymore, does she? She could be putting anything into that hat. Now, of course, 12 ASCII characters isn't really that long of a message. So if you wanted to encode something longer, you're going to need to knit something bigger. This scarf here actually represents the source code to the website Ravelry.com, which is essentially GitHub for knitters. It's both an immense catalog of cross-referenced patterns, projects, and yarns, and it's a social network of sorts with forums as well. And so this particular knitter, Hey Carrie Ann, converted the homepage HTML of Ravelry into binary and knitted that into a scarf with knit stitches as ones and purls as zeros. Now, if you want to be more literal, you could actually knit little ones and zeros into your scarf. You may be interested to know that depending on how tall you are, your average scarf will hold about 120 bytes of information in this way. Not even a tweet, really. Now, if you are more of a black hat type, and you may well be, because after all, Troy Hunt's session is the next one, you can actually knit a computer virus, not just a real virus, a computer virus. In 2001, a team of activists at the Viral Knitting Project did just that. They knitted the source code to the code red computer virus, remember that one, into a scarf. So forget your COVID, the scarf shown here in this image is literally malware. In fact, the scarf that I am wearing is in fact malware. It comes from an artist named Jeff Donaldson, and he goes by the name Glitch House online, where he sells a range of scarves and homewares that he calls malware, get it, that actually encode famous malware. And so this scarf, I backed his Kickstarter. This is actually the I Love You virus that took out most of the internet on a super fun day back in the year 2000, for those of you who are old. You can even get like Stuxnet as a throw if you need something to put on the back of the sofa. Now, I myself was tempted to knit some malware a few years back. I was entering the Sydney Royal Easter Show knitting competition, sort of like the state fair for those of you in other places. And after several years of not getting a ribbon and being kind of put out by this, I decided to have my revenge on the judges by tricking them into visiting a, shall we say, unsavory website. So I designed and knitted QR code mittens. Now, these are really difficult to get to work. The biggest problem is that QR code readers really rely on everything being quite square. But knitted stitches are inherently rectangular. They're wider than they are tall. So I went through many a failed prototype before hitting on the highly technical solution of stretching the hell out of it. So eventually I did get a version that worked. And you can actually scan that without fear, because my husband did put me out of my evil plan. So instead, the QR code points you to a page on my website that has the pattern for the mittens. So they are, in fact, self-replicating. And hey, they won me second prize. Now, a new field that's gotten attention in recent years is data art or information art, and that can also be knitted. You might have seen this go viral last year. A German woman named Claudia Weber knitted a scarf to track the delays on her commute to and from work each day. It'd be kind of funny knitting one of those in 2020, huh? Every night she'd knit 2 rows, gray for delays under 5 minutes, pink for delays up to 30 minutes, and red for delays over half an hour. And as you can see, Claudia had a very bad month in there. She eventually auctioned this scarf on eBay to raise money for a German charity that provides assistance to folk at train stations. This is another one I like. A group of radical knitters started the Tempestry Project, which is an effort to assist climate change discussions by scaling the problem down into something accurate, tangible, relatable, and beautiful. So each tempestry, that's what they call these, actually represents the daily high temperature for a given year and location, with January at the top and December at the bottom. So you knit them all using the same yarn colors and temperature ranges, and as you can see, they're getting rare as the years go by. And the website has instructions and kits for making your own if you'd like to contribute. Another project that went viral last year that I really like was Seung Lee's sleep blanket. This is very cute. It documents the first year of his baby son's sleep patterns. So Lee collected sleep data by manually logging it into an app, and then he used JavaScript and Python to convert that data into a visualization. He then built a browser-based tool to keep track of the stitch colors and keep track of where he was in the pattern so that he could knit wherever he went. So the blanket actually consists of 185,000 stitches. It took more than 3 months to knit. And each row represents a single day, with the top row is the day the baby was born, and bottom row is baby's first birthday. And every single stitch represents 6 minutes of time spent awake in gray or asleep in blue. Isn't that lovely? This is another visualization I really like. This was called the Neuro Knitting Project. So with this one, creators plotted brainwave activity and turned it into a knitted accessory. So they used wearable EEG, as you can see there, to record users' affective brain states while they listened to a piece of music, Bach's Goldberg variations, and then they knitted that into a scarf on a hacked knitting machine. Yes, hacked knitting machines are a thing. If you didn't know, machines have actually been around for a really long time. They were very popular in the 80s, like Brother, the computer printer people, they made a lot of them. But hacking them has only really gotten popular in recent years with the knitting geeks. Some of the old ones, and I've seen these in person, use actual punch cards to input the patterns. But others were computerized, you know, they had stitch patterns built in. Some of the really fancy ones had floppy drives or even a special cable that you could use to transfer your own designs over. So hacking one of these usually involves making your own serial cable and using software to transfer new custom designs to the machine. So there's an open hardware project called Knittic that uses an Arduino as a new electronic brain for the machine and allows you to manipulate designs on the fly. And you can do some really cool stuff with this. So my friend Sarah Spencer, she is a developer in Melbourne here in Australia, and she turned a dumb 1980s knitting into a wireless knit printer using a Raspberry Pi, Arduino, Python, and some custom hardware builds to upgrade its components. That thing on the front there is actually a custom color changer that she designed and built with her partner, and which, along with a new multicolor algorithm, allow her to use 3 separate colors in any given row. She actually used this machine to make the custom Hamilton blanket for me that you can see behind me there, as well as, brace yourselves, stargazing, a knitted tapestry, and look at her in the corner there for scale. This is an enormous star chart of the visible galaxy. It measures 4.6 meters wide by 2.8 meters high and used 15 kilograms of blue, white, and gray wool. Sarah actually presented this at EMF Camp 2018 in the UK. You might be able to look that up. And she also spoke about her hack knitting machine at LinuxConf 2018 in the Art and Tech mini-conf that I organized, and you can watch that talking too. There's one last hack knitting machine project that I want to mention, which is Knityak. Knityak, you might have seen a few years back. It had a Kickstarter that went really viral. Fabienne Serriere, FBZ on Twitter, she wanted to use a hacked industrial knitting machine in a shipping container in Portland, because of course, to knit provably unique scarves using elementary cellular automata. Elementary cellular automata, you know those, right? Like in Conway's Game of Life, and we should all quickly pour for Conway, recently deceased. Now, with these automata, I can start off a project with a one-dimensional pattern of ones and zeros. So whether those be different colors or knits and purls, and then according to rules, that pattern will evolve over time. Now, this here is an example of Rule 110. And around the year 2000, Matthew Cook published a proof that Rule 110 is Turing complete and is capable of universal computation. And I can knit this sucker. Do you realize what this means? Given an infinitely long ball of wool and a set of needles, I can simulate any Turing machine, and by extension, the computational aspects of any possible real-world computer. That's pretty cool. So hopefully by this point, you're getting the idea that there is some significant overlap in the Venn diagram of knitting nerds and computer geeks. And as someone who proudly sits right in the middle of that diagram, there is one question that's been bouncing around my head for the last few years. Could a computer read knitting? Now let me explain by what I mean by reading knitting. This is a photo I took of my colleague Mega's jumper in our office kitchen last year. I'd never seen the particular stitch pattern before, so I snapped a photo because I'm a weird knitter and that's what I do. So looking at this, I can tell you immediately, okay, the background there, that's reverse stocking stitch. And those raised zigzag lines, those are 3 knit stitches. They use a combination of decreases on one edge and increases on the other to make them lean to the left and right. Some of that I get by recognizing the texture, by knowing how stitches work. I can also zoom in and read it stitch by stitch, like deciphering someone's cursive handwriting. And this, my geeky friends, this is reverse engineering. It's basically me doing a clean room design of Mega's sweater. So if I can do that with my eyes, could I train a machine learning model to do the same? Now, hopefully you watched Nick's talk before mine about machine learning, but I'll be upfront. Before I started this project, I knew pretty much jack about machine learning, okay? But I happen to work at AWS, and I work with some very smart people. And so I took one of them to lunch. I told her about my idea, and she went, oh, someone's just done that. Well, crap. She sent me this paper. Yes, there are academic papers about knitting. Didn't know if you knew that. Inverse knitting from images to manufacturing instructions was presented at the International Conference on Machine Learning in June of last year. So the goal of this research team was to take a picture of some knitting, reverse engineer the pattern, feed that back into a knitting machine, and get an identical swatch back out like a piece of knitting. Basically, they want to build a knitting duplicator. Now, they recognized very early on in the project that photographs of knitted fabric really suck for computer vision because they're floppy, they're stretchy, they're often fuzzy depending on the wool you use. So the real breakthrough in this project was they augmented their training data, not just using real knitted swatches, but also using simulated knitting from an industrial knitting machine, the software that comes with them. And they realized that training a model on both real knitting and the simulation of it would give much better results. Now, I'll be honest, this paper has a lot of calculus in it, and it's been a while, so most of it went right over my head. But from what I could tell, they haven't quite cracked it yet. They're getting close. They've managed to get to about 80% accuracy with their experiments, which utilized both convolutional and generative adversarial neural networks. Okay, so some very smart people are already working on this, and chances are they're going to solve it way before I am. That kind of takes the pressure off a little bit, right? So with that in mind, I decided to cut my scope way back. And rather than focus on reading a pattern stitch by stitch, I decided to just treat it as an image classification problem. So here's the plan as I saw. Get some training data. How hard could that be? Label it, train up a machine learning model, deploy it somewhere, maybe build a nice little web front end so I could do some inference, and then, you know, dance on the wave of the 1,500-year-old knitting industry, right? Easy peasy. So because I'm a masochist who has no idea what I'm doing, I decided to crowdsource my training data. So this is the tweet that I made last October asking for knitted samples. I decided that I was only going to focus on a handful of basic stitches. Stockinette stitch, garter stitch, seed stitch, and moss stitch. So these are just 4 very basic ones made up of knits and purls. And I figured that by limiting it to just a small number of classes, that would maximize my chance for success. And so I wrote up a blog post about this where I specified exactly what type of images I wanted, you know, close up of the stitches. I also talked about what I didn't want. And actually, then I went to AWS and I built myself a pipeline. I didn't want to have to manually download these from people. So what I did is I used a number of services that we have. And basically, when an email came through, a Lambda function, a serverless function, would take the attachments and put them into a bucket in S3. So I knew I was going to need them in S3 anyway, so it just made it a whole lot simpler. So I put this email address out there. I put this in a few places on Ravelry, and I shared it on Twitter. And the good news is that it's kind of started to take off viral a little bit, at least among, you know, the knitting geeks. It got retweeted more than 350 times. I got like a reply from Janelle Shane, who does those cool, like, if a machine learning network like named cats and stuff like that, like she replied to me. And so she's kind of cool. People started tagging and forwarding it to their knitting friends. And more importantly, images started to arrive in the S3 bucket. Like random human beings around the world were being so generous and getting behind my project. And my heart was just bursting. But the bad news is that they're human beings. And well, all my care plans got tossed out the window pretty quickly. I ended up with about 400 images off the back of this, and I'll just show you a selection of them. So some folks sent in finished knitting photos, you know, whole garments, which were lovely, but didn't quite have the resolution that I needed to zoom in and see the actual stitch patterns. One lovely lady messaged me on Ravelry and said, "Oh, I've sent you several knitting images. I also think I might have sent you some Halloween candy because I couldn't figure out how to delete the attachment from the email." Somebody on Twitter just replied to my tweet with a bunch of links to Instagram, like, no, I'm not going to scrape them off your Instagram. Or people just replied to my tweet directly with photos. A lot of people sent in stitches that were not the 4 ones that I asked for. Somebody sent me a Calvin and Hobbes comic, and I really have no idea what's going on in that one in the lower right there. So the first big lesson I learned is that even with the best of intentions, people are people. They get excited. They don't read very closely. And I don't mean to shame or make fun of these folks. Like, they were being so nice. They were generously trying to help me out. But crowdsourcing your data just comes with a really big risk attached. And I should have known. Every article about machine learning says that you will spend most of your time cleaning up the data. And now I have firsthand knowledge of why. Okay, so at least I had some images. And I needed to get them labeled, or at least get the good ones labeled. So again, I put the call out to my mighty knitting army. I used here an AWS service called SageMaker Ground Truth. And this held accurate training data sets for machine learning. So if you haven't seen it before, this is what the Ground Truth interface looks like. So basically, I loaded up, I pointed at my S3 bucket. And so a volunteer, I had a team of volunteers, would log in. And I used knitters for this. I didn't want to use random muggles because you wouldn't know. So I used knitters, and they would look at the stitch and then choose from the option on the right side there. And you'll see I've got a couple 6 options there. Included reverse stockinette, which is the back side of stockinette stitch, because a lot of people had actually sent me that, and I thought, okay, why not? And then also other, which was used for anything else. And I configured the system so that every image would have to be reviewed by at least 3 different people, just to minimize the chance of errors. And I was very lucky I did that, because I quickly ran into another problem. All right, on the left here, you see garter stitch, which is what you get when every single row, no purling. And on the right, what you see is reverse stockinette stitch, where you knit 1 row and then purl 1 row. And this is the back side. And they kind of look a lot alike. In real life, they're very easy to tell apart, because one's the same on both sides and one is very different. And if you stretch garter stitch, it kind of has these ridges. But in a flat photograph, they can be really hard to tell apart. I actually had a hard time distinguishing between. And so I realized pretty quickly that my labels for these 2 were going to be kind of useless. Now, the other 2 stitches I included were seed and moss stitch, which I thought, those are easy to tell apart, right? See the photos here? Like, totally different. And then I discovered that in British patterns, they use both words to refer to the same pattern, the one on the left. Only Americans call the one on the right moss stitch. So again, those labeled images also completely unreliable. So crap. Anyway, here's the end result. This is what the end result of my ground truth labeling job looked like. So I realized that with the limited number of good images I had, the unreliability of the labels, I needed to descope even further. Rather than trying to identify between 5 different classes, let's just identify one, a single one. You know the hot dog or not hot dog from Silicon Valley? Yeah, my goal is just to build stockinette or not stockinette, okay? So I had to train and deploy the model. There are a lot of ways you can run machine learning algorithms. Jupyter notebooks, data science people really love those. My Python is kind of rusty. I just used Amazon SageMaker within the console. It's fully managed and it kind of covers the whole thing. And I found some tutorials that walk me through it. I ran my training jobs on a single P3 instance. That's basically a really powerful virtual machine with powerful GPUs to accelerate machine learning. I gave SageMaker all my images in the S3 bucket. I gave them the labels from my training job and kicked it off. And it took me 7 tries to get a job that I actually finished. Told you I sucked at this. But eventually I got a model. And I used SageMaker to deploy that and host a production endpoint for a really simple web front end. And then it was time to try it out. And I very carefully fed in an image of stockinette stitch. And holy crap, stockinette stitch. That is actually correct. I have nailed this machine learning thing. I am a golden god. Where is my PhD? Oh, maybe I should just drag in a second image, to confirm and be sure. Okay, wait a second. That is not stockinette stitch. That is actually garter stitch. Okay. Crap. That's not even knitting. That's crochet. You know how I feel about mixing those 2 things up. So with a sinking feeling in my stomach, I tried one last image. That, my friends, is a cat. That's not stockinette stitch. So rescind the PhD. It turns out that this is often the case with machine learning. It is extremely unlikely you hit the jackpot on your first go. And when I went digging in my logs, I could see that my training and validation accuracy were actually 57 and 45%, more or less a coin flip. So back to training again. I ended up running more than 15 different training jobs, trying to figure out the magic combination that would give me the best result. To minimize the effects of image size and color, I cropped them all to a fixed size. I converted them to grayscale. I also rotated each image, which meant that I had more images in my training data set. I also added in clutter, which was like dinosaurs, accordions, and airplanes, and stuff was not knitting. So I had more examples of those. And I ran a hyperparameter tuning job, which sounds very fancy, but hyperparameters are kind of just what they sound like. They're a bunch of parameters you can twiddle to maximize your algorithm efficiency. And rather than try out thousands of combinations myself, I found out that SageMaker makes it easy to run an automatic tuning job, and it'll try out dozens of combinations for you and figure out the one that works best. And eventually, this is where I got to. Boom! Folks, every single one of those is correct, except for that last one, which is a weird stitch. I think maybe a brioche stitch or something like that. It kind of looks like stocking stitch, so I can actually see why it got confused and mislabeled that way. But even the cat, it labeled correctly, is not stocking out. So now I am up to 95%, nearly 95% accuracy, which is very cool. So obviously what I want to do now is to go and expand from just stockinette to try and bring those other stitch classes back in, which means going back to my crappy training data and trying to clean it up and get clean training data to work from. Now, if you're curious, the total cost for this project, around 25 bucks US, most of which was because I ran those training jobs over and over again, which isn't too bad considering how much trial and error I went through. So in conclusion, I will not be disrupting the well-established knitting and textile manufacturing industry anytime soon. But between me and those neural inverse knitting researchers, I reckon we will probably see a knitting replicator before the decade is out. Just going to mention some thank yous as I wrap up here. The dirty little secret of machine learning is it actually involved a lot of human beings clicking a lot of buttons. So 53 different knitters sent in images to me. A team of 14 knitters collectively spent nearly 15 hours labeling over and over again more than 3,000 images. And I also benefited from a lot of advice and guidance from my colleagues, Aparna Alangavan and Gabe Hollenby. So I hope this has entertained and inspired you a little bit today. I hope I've shown you that there is more to knitting and craft than just lame memes and grandma jokes. After all, Granny was a hacker. These here are some of the many things I've knitted. Each one of these taught me a new technique or stretched my skills. And that's one of the things I find really annoying about tech is that whenever you want to learn a new framework, it's always a to-do list app. I don't get excited about that. We need people to push the boundaries of what can be done. So if you're finding it difficult or you're not inspired to learn something new, my suggestion to you is try and think of a way you can solve a real problem. Bringing something into existence that wasn't there before is a really fantastic motivator. And if I have inspired you to learn to knit, there are some really fantastic tutorials on YouTube. Hey, if you donate today to Direct Relief, hit me up. I will actually do a Zoom knitting lesson with you free of charge. So thanks again to the Dev Around the Sun folks. And please don't forget to donate to Direct Relief. And hopefully I can toss back over to the MCs. You ready, Lars?